Okay, in this video we're going to practice some solubility and insolubility testing on these various compounds. What I'd recommend you do right now is pause the video, go through these compounds, and write down or think about whether or not they are soluble or insoluble. So, pause the video right now. Okay, now that you've presumably unpaused it, let's go through them. First one, sodium chloride. I'm going to be marking that one as soluble. Main reason that one's going to be soluble is because sodium is going to be one of our alkali metals from one of the group 1. Next one, we have calcium nitrate. That one is also going to be soluble. All nitrates are soluble, no exceptions. Next up, lead sulfate. If I go down here, sulfates are all soluble with the exception of silver, mercury, and lead. So this one is going to be insoluble based upon these exceptions there. Next up, sodium carbonate. Don't really need to check this one for sure because we know it's going to be soluble. All alkali metals and ammonium are going to be soluble. Sodium bicarbonate. Again, we know that one is going to be soluble. It has a sodium inside there. Anytime it's got a sodium or any of the alkali metals, no exceptions, going to be soluble. Next up, silver chloride. Chlorine is going to be a halide. Those are going to be soluble with the exceptions of silver, mercury, and lead. So that one would be insoluble because of the silver there. Next up, potassium hydroxide. Hydroxides are going to be insoluble with the exception of anything that's an alkali metal. Potassium is an alkali metal. This one would be soluble. Next up, calcium phosphate. Phosphates, by and large, are going to be insoluble. The exceptions are alkali metals and ammonium. Calcium is not one of those. That's going to be another one that's insoluble. Strontium hydroxide. Hydroxides are going to be insoluble with only these exceptions. In this case, this would be an exception. This one is soluble. Another way that we could look at this is just kind of go down the list and everything that is an alkali metal, mark that as soluble. There's no exceptions to that when you don't really need to think about it. Same thing with the nitrates. So just one way of doing it is just jump down. That'd be soluble, that'd be soluble, that'd be soluble, that'd be soluble, because there are no exceptions to those rules there. Same thing with nitrates. Focus on the stuff where there are no exceptions. So I have this reaction here, rubidium phosphate plus aluminum nitrate makes rubidium nitrate and aluminum phosphate. We need to figure out which one is going to be the precipitate. Well, we know for a fact that all nitrates are going to be soluble, therefore this one is going to be aqueous. We know for a fact that this one will be able to dissolve in water. The second one, aluminum phosphate, going down the list there, phosphates are going to be insoluble. The only exception is the alkali metals and ammonium. This one isn't either one of those. This means that this is going to be the precipitate in my reaction. That'd be this part that comes out of it. So let's balance this equation first. Zinc chlorate plus potassium carbonate equals zinc carbonate and potassium chlorate. First thing I'm going to do is I'm going to put a 2 for my coefficient here. That's going to sort of balance it out left and right. Now I need to figure out if stuff is going to be soluble. Chlorates are going to be soluble, no exception. That means this one's aqueous. Carbonates, those ones are insoluble, but even before that, the alkali metal, the potassium, is going to trump that. We know this one is also going to be soluble. This one is going to be aqueous. Then we're left with zinc carbonate and potassium chlorate. Well, we know that my carbonate is going to be insoluble with these exceptions. That's not one of them. And potassium, I don't even need to read the rest. I know that that one is going to be the aqueous. So this means that my zinc carbonate right here is going to be the precipitate in this particular reaction.